Alright guys, your central question for today is how do we use the law of cosines to solve triangles? Your vocabulary is law of cosines, and you will have a test over this material at a later date. Okay, now, so far the only law that I've taught you is the law of sines. And I taught you the law of sines because it helps you solve non-right triangles. It even helps you solve right triangles, but it's really just used for non-right triangles, oblique triangles. So let's say that I gave you this problem. Let's say I wanted you to find the length of side C. And all I tell you is that side A is 7 and side B is 9 and angle C is 23 degrees. Well, the issue is I can't use the law of sines because I don't know what any one of the angles that's paired with any of the given sides. So in other words, I can't just find this. I can't use the law of sines because I'm not given enough information. That's where the law of cosines comes into play. Here's basically the main thing about the law of cosines. Now, it looks like there's three separate formulas, but in reality, it's just one, and the other two are just different ways of writing it. Basically, let's say you have a triangle ABC, where angles A, B, and C are in capital letters, and lowercase a, B, and C are your sides. If I ever give you two sides and the included angle, then you can use the law of cosines to find the side of that included angle. And so that's what this formula says. I'm going to rewrite it again. It says that if you know A, and if you know B, and if you know the angle that's between them, you can find side C. And so that's what this formula says. C squared equals A squared plus B squared minus 2AB cosine C. It looks kind of like the Pythagorean theorem. In fact, you can derive the law of cosines from the Pythagorean theorem. For example, if I just covered this up, you see A squared plus B squared equals C squared. The only thing that's extra is this minus 2AB cosine C stuff. So that's why this works for any triangle that might not necessarily be a right triangle. Okay, so one thing I do want you to notice, though, is that if you want to find, like, side C, in order to solve for C, you'd actually have to take the square root of both sides, and then that would give you the real formula. C is equal to the square root of A squared plus B squared minus 2AB cosine of C. And this is really like the most used law of cosines formula. So that's the one I'm going to be referencing as we do some problems. Speaking of which, let's go ahead and look at an example. Let's say that I wanted you to solve the following triangle, and I tell you that angle A is 120 degrees, so I'm going to go ahead and do that. There's angle A. And then side B is 9, and side C is 5. I guess I should have written those a different way because it would look more convincing, wouldn't it? So let me do this again. Side C is 5, and side B is 9. Well, I want you to notice that I give you a side, and the included angle, so therefore I can find what the opposite side is of angle A. So in other words, I can find what angle A is using my law of cosines formula. So the formula would be A is equal to the square root of 5 squared plus 9 squared minus 2 times 5 times 9 cosine of 120 degrees. Now I'll go ahead and tell you that where most people mess up is the fact that they use sine instead of cosine. That's where the problem is. So we're just going to type this in like I see it. So 5 squared plus 9 squared minus 2 times 5 times 9 cosine of 120 degrees, and that would give me the square root of 51, which would give me 12.3. And I'm going to type that in just one more time to be on the safe side. So the square root of 5 squared plus 9 squared minus 2 times 5 times 9 times cosine of 120 degrees. Yeah, that'll give me 12.3. So that's what side A is. Well, now that you have side A and angle A, you can use the law of cosines because, see, we can pair up side A, which is 12.3, and angle A, which is 120 degrees. So I can use the law of sines now. So I'm going to have 12.3 over sine of 120 degrees equals, doesn't matter which one I'm going to do, 5. 5 over sine C. I'm going to cross multiply, so I get 5 sine of 120 equals 12.3 sine of C. I'm going to divide by 12.3, but since I'm trying to find the angle, I have to do sine inverse. So sine inverse of 5 sine of 120 over 12.3. And so let me see what that would give me. 5 sine of 120 divided by 12.3, and I'm going to do sine inverse of that, and so that would give me about 21 degrees. So this angle right here would be 21 degrees. I could quickly find angle B by simply doing 120 plus 21 and subtracting it from 180, and so this would give me 39 degrees, and that's it. I've got all three sides now and all three angles, so the whole triangle is solved. Got it. Alright, let's look at one more example. And in this case, notice that I don't tell you any angles. I just tell you what the sides are. So I'm just going to call this A, B, and C. And what I tell you is that side B is 40, side C is 18, and side A is 24. Well, in this case, where you're asked to solve the triangle and you don't have any angles, what I suggest you do is try and find the biggest angle first. Now, I'm just going to write out the formula so I remember it. B squared, in this case, so I'm trying to find angle B. B squared is equal to A squared plus C squared minus 2AC cosine of B. Now notice that B is what you're trying to find. So I'm going to have to do some manipulation once I start plugging this stuff in. Well, B in this case is 40, so I'm going to have 40 squared equals A in this case is 24, so 24 squared, plus C in this case is 18, so 18 squared, minus 2 times 24 times 18 cosine of B. And so I'm just going to do some arithmetic first. 40 squared is 1600. 24 squared is 576. 18 squared is 324. And then 2 times 24 times 18 is 864 cosine of B. And then I'm going to go ahead and combine my like terms, my 576 plus my 324, that's going to give me 900. And then to solve this for B, I'm going to subtract 900, so 1600 minus 900, that's going to give me 700, is equal to negative 864 cosine of B. Be careful here, guys. You're not going to add 864. You're going to divide by 864, and then while I'm here, notice you're trying to find angle B, so I'm going to do cosine inverse of negative 700 over 864. So if we just type this in, cosine inverse of negative 700 over 864, that's going to give me 144 degrees. Now, here's what's interesting is that if you start with the biggest side, you'll always end up with the biggest angle. So I noticed that this is obviously my obtuse angle, so that's going to be my biggest angle. And so now that I've gotten one of my angles, I can pair up my angle with my side, and now I can simply match this up with, doesn't matter which angle, I'm going to just do angle A. So I'm going to do law of sines now. So I'm going to have 40 over sine of 144 equals 24 over sine of A. Now here's where the issue that most people mistake is that they mix up the sines and the cosines. They might put cosine here instead of sine. So you got to remember your formulas. So I'm going to have 40 sine of A equals 24 sine of 144. To solve this for A, I'm going to divide by 40. But since I'm trying to find angle A, I'm going to do sine inverse of 24 sine of 144 over 40. And if I do that, 24 sine of 144 divided by 40, and then do sine inverse, that's going to give me 21 degrees. And now I can easily find angle C by adding 144 plus 21 degrees and subtracting that from 180. That's going to give me 15 degrees for angle C. And now my triangle's solved, so I'm done. And that's all for the notes for today.